Okay, so the Dr. Steeson here again. So in the first video, I showed you how to create new variables, and there were two ways which you can do that. You can compute a new variable where you add existing variables to get a whole brand new variables, or you can also use the recode into different variables. You always want to do that so that you don't make any changes to your original variable should you need to go back to it or if you've made a mistake. So those are two ways you can create new variables. And then I showed you once we got the variables down to from 3 and 4 categories to just 2, they became dichotomous variables. And so we also converted all of the benefits into one variable and all the barriers into one variable and treated that as a quantitative variable. And then we could do t-test analysis. Now, there's another test that I want to show you, and this is the logistic regression analysis. Now, the outcome here is dichotomous. With a logistic regression, it's used to determine whether certain variables are associated with the outcome. And if it's a binary logistic, it's either or, yes or no. And in this case, I wanted to use the progress variable because that is a binary variable in that it's either the teacher or the therapist considered the student to have made progress or not during that the period of assessment, right? So if we did the statistics, the descriptives on that variable. This is the progress variable here. We have 30 students, 12 of which were considered to have progressed, 18 of them not progressed. So we can use this variable as the outcome variable, and then we can determine which of our variables or covariates are statistically associated with this particular outcome. So to do that, we will go to our analyze, regression, binary logistic regression. And here I had set this up where I had taken the student progress and used that as the dependent variable. And then I had professional years of experience as one of the variables. I also had satisfaction. I recoded all these variables from the original variables, and this is my zip code recode, which I want to place at the top because I think that's the most important one. So now that we have all that set up, we would go in here and make sure that we are indicating these variables as categorical. You move them from the covariate over to categorical. And if the variables have any order to them, you can tell SPSS which ones you want to be the reference. So, for example, professional years, if we make the first one the reference, then it will be the category with the lowest number of years of experience would be the reference. Similarly, for the time plan, that's also the first one is the recode, service is the same. So now we can go ahead and generate our logistic regression analysis. And here we have a logistic regression. We're going to get, a bunch of tables, some descriptive statistics, some case reports. There'll be generated a regression with no variables. And then when you get to the block one, this is the one that we're interested in. And this is the table that will tell us whether the variables are statistically significant or not. So we have the zip code variable. It is statistically significant based on this value. And we also have years of professional experience that's also statistically significantly associated with the outcome of progress versus no progress. And we can see that the category for the one just above the reference, which is the second most, is statistically significant. And here we had the zip code, we had urban and rural. Urban is associated with progress as far as a student, but the odds are extremely low. And of course, that's because we have such a small data set. But this is something that you can do. You can generate a logistic regression. You can choose any one of the other dichotomous variables and then run them with this to determine if there's a significant